Okay, great. Good morning, everyone. I'm Stephen Ritchie and former director of ITS Irvine, and I'm delighted to welcome you to today's Emerging Scholars Transportation Research Symposium. This event represents a celebration of intellectual curiosity, innovative thinking, and the remarkable dedication of our student researchers who've spent the summer at the forefront of addressing some of our most pressing transportation problems and challenges. Today, we've got a special opportunity to witness this next generation of transportation scholars present their groundbreaking work. We look forward to hearing their insights and their contributions to this evolving dialogue about the future of mobility in our communities and beyond. A little background about our programs. This is actually the fourth year of the ITS Summer Immersion Programs, comprising TRIP, which is the Transportation Research Immersion Program for undergraduates, and PRIME, the Pre-College Research Immersion for high school students. So this year we had 17 students, which is awesome, 11 undergraduate, 6 high school, and we had 8 faculty participants dedicating their summer to working together on 13 research projects. Our faculty were from several disciplines, including civil and environmental engineering, mechanical and aerospace engineering, and public health. And our high school students hailed from 5 different California high schools, as far north as Bay Area and to San Diego in the south. Our undergraduates this year included students in the fields of engineering, public health, mathematics, music, computer science, urban studies, and journalism. And the success of these programs, I think, is particularly noteworthy because the experience that these students gain in both Prime and Trip carries through as they continue on in their education. Last year, all of our Prime high school graduates enrolled in post-secondary educational institutions, and all Trip undergraduate alumni accepted graduate school or STEM-related employment offers within 2 months excuse me, of graduation. And TRIP alumni also excelled in many other ways, receiving internships, scholarships, and several even participated in published transportation-related research. So, as you know very well, transportation systems form the backbone of our modern society. They connect people to opportunities, move goods to markets, link communities to one another, and yet as our world becomes increasingly urbanized and interconnected, we're facing unprecedented challenges: climate change, demanding sustainable solutions, equity concerns requiring accessible transportation for all, technological disruptions that reshape how we move, and infrastructure needs that must balance innovation and resilience. So the research being presented today tackles many of these complex issues head on, demonstrating that our emerging scholars are not merely observers of these challenges, but active participants in developing solutions that will shape our collective future. So the work being presented today really spans a diverse array of topics within transportation research, from advanced air mobility to sustainable and equitable transit systems. And I think what makes this symposium particularly special is that it showcases fresh perspectives and innovative approaches that our student researchers can bring to the field. Our emerging scholars really offer unique insights and challenge assumptions and open new avenues for exploration. I'd like to acknowledge the faculty mentors who've guided these students through the research process, sharing their expertise while encouraging independent thinking and creativity. Your commitment to research excellence is evident in the quality of the work being presented today. I also thank our staff and the sponsors who have made this symposium possible, recognizing that fostering student research really requires a community effort and a shared vision for developing this next generation of transportation professionals and scholars. And special thanks, of course, go to Dr. Victoria de Guzman for conceiving, organizing, and leading our ITS summer programs, of which this symposium is a premier event. So as you listen today to the presentations, I hope you engage in discussions and network with fellow attendees. And I encourage you to ask questions, share ideas, and consider how these research findings might inform your own work or inspire new collaborations. This symposium is not just about presenting research. It's really about building a community of scholars, practitioners, and advocates who are committed to creating transportation systems that are safer, more sustainable, more equitable, and more responsive to the needs of all users. So in closing, to our presenting students, be proud of your accomplishments. Know that your work matters. You are the emerging scholars who will lead transportation research and practice into the future. Thank you very much.
I'd like to now invite our host, our student host, Melissa Lepe, to kick off the rest of the event.
Thank you, everyone, and welcome to our student presentation. So the students have been working a really, really long time over the summer. They worked really hard. So today's the time to celebrate some of those efforts that we've seen them come. So we like to welcome the faculty advisors who are around the room, as well as the students. And I know we have some parents in the room as well who are here. This year, as was mentioned, we have a pretty diverse cohort of students. We have some students who are coming from UC San Diego. We have students from different majors. We have a high school student here present. We even have students who are majoring in viola, as I heard. So we have a wide array of students coming with different perspectives and different ideas. And really, it's a time to celebrate some of the work that they've done. And I think with that, I'd like to welcome the first student who's going to be presenting today, as well as their faculty who will be announcing them.
Awesome. Okay. Thank you, Melissa. Yeah, good morning, everyone. It's my pleasure to introduce the high school student, excellent student, Alex Wang. And Alex actually is from the Troy High School. And I don't know if you know the local high school system. Troy High School is renowned for its excellent STEM program. Actually, you have to take a test to enter to be admitted to that program. It's a public school. So it actually serves multiple districts. Some students from Irvine, from all these places go to Troy High School. And Alex is one of the excellent student, very motivated in programming and mathematics. I could immediately tell from his resume, and then from the way he picked up the technical details. And today he's going to talk about this topic, a little bit background to this one. And actually he worked with June, with my PhD student June. And the big picture is that we are trying to analyze the data for the conversion project on the 405 from HUV LAN to HOT LAN. And we want to look at the data before and after to see the practical impacts on equity. For example, how this would impact the general purpose lanes mobility. And then actually there's also big theoretical foundational context or motivation for this one is to look at the very well known for many of you in transportation. The transportation planning is built on the so-called the link performance function, especially BPR function. However, to the best of our knowledge, there's no big data verification, calibration of that. And with this project, we hope to to provide the big data evidence to prove it or disprove it. So that is the background. Now I as said, I mean, Alex has been fantastic to work with June. June has been very helpful and to make solid progress towards the final goal. And I'm excited to look forward to Alex's presentation.
Thank you very much. Good morning, everyone. My name is Alex Wang, and I'm a senior at Troy High School in Philippines. Today, I'll be presenting on my project on the automatic identification of week-to-week traffic stationary states. Firstly, this project is meant to identify these week-to-week stationary states in an automatic manner. A week-to-week stationary state is one in which the flow rate and density remain consistent for the same weekday across a period of multiple weeks. So for example, we would expect that rush hour patterns on Thursdays every week should remain roughly consistent. In practice, this sort of perfect consistency is unachievable. There will always be stochastic fluctuations in flow and density for every week. So we deal with these week-to-week near stationary states in which the difference is below a certain threshold. The figure on the screen here shows a stationary state on the density axis. So as you can see, all the curves are relatively similar. And so this project seeks to identify when and how the road state will behave predictably. The inspiration for this methodology comes from another paper, Yan et al. 2017. And it's a method of identifying stationary states within a day. So we would see that like a 4-minute interval, if you will, where traffic remains relatively stable. Said paper also utilizes the Pelt method, which I'll explain later on. But this approach uses more techniques suited to one-dimensional time series analysis. So this project is an extension of this into multiple dimensions for this week-to-week stationary state analysis. Data was collected using 352 daily flow and density curves from sensor VDS 1203506 in Buena Park. It's an aggregate of 4 lanes, and so the data was collected between 2011 and 2017. A period, so 2 periods in this data set were discarded because of the lack of sensor uptime. The minimum granularity provided in the PEMS data set is 30 seconds, but we used 5-minute data intervals because this reduces some of the variance and noise in the data. This method has 3 steps. Firstly, we can use heuristic threshold values. That is the value at which a curve is considered too non-conformal for a segment. I'll go into this a little more later. And we iterate over penalty values using the Pelt method to find the one which has the most meaningful state candidates. With this appropriate segmentation, we can determine the maximum distance threshold that are best for the outlier detection. And if the initial and final threshold values have a significant difference, we can reiterate this method with a different initial threshold. We discard segments with length 2 and below as we consider them insignificant to be determined as a week-to-week stationary state. To segment our flow and density vectors, we use the Pelt method. Pelt is a method which Pelt stands for pruned exact linear time. And it's a method in which, as stated in linear time, we can find a method of segmentation which reduces the variance amongst individual segments in a time series. We can minimize over and underfitting through our choice of the penalty value, minimum distance, and the threshold. That is the value which the Pelt method seeks to minimize. It's a sum of the cost function and a selected penalty value. We will use the radial basis function kernel for our cost function. Firstly, as we stated, that data is collected in 5-minute aggregates. So every day's flow and density curves can be represented in a vector of length 288. The radial basis function kernel transports each 288-dimensional vector into a higher dimensional Hilbert space. And since the space cannot be worked with directly, we utilize the kernel trick. The benefits of using the radial basis function kernel over here is that we can identify like the underlying distribution in which the traffic curves come from. Okay. So, sorry, I explained this already. The original method used in the previous paper that we were trying to extend used L2 Euclidean distance, and we just believe that the radial basis function distance is more robust than this distance metric. This plot more intuitively shows what we're trying to accomplish here. The blue plotted line indicates the distance from the distance from the segment mean. So it's so the segment mean I'm here referring to is the kernel mean, right? For between each of these dotted vertical lines is a candidate for a week-to-week stationary state, and the blue plotted line indicates the distance of 1 day's flow and density vectors from the mean of the state candidate. The leftmost segment on the screen right now is valid due to the fact that it does not cross the threshold and is also above the minimum length threshold of 3 weeks. The middlemost segment is invalid because it is only 2 weeks in length, and the rightmost threshold and the rightmost candidate is invalid because one of its data points crosses the threshold. So that means it's too abnormal to fit inside this stationary state. So now we go into what we the actual experimentation with the data. Using our heuristic threshold values, we can find the penalty value with the most valid segments. The segments are defined as the points between two consecutive breakpoints in the change point union of flow and density. So we apply the PELT method separately to both the flow and the density time series, where we take the union of these two. So by selecting the one with the most valid candidate intervals, we can minimize over and underfitting. If we overfit, many of the intervals will fall below the distance threshold that we set at 3 weeks. And if we underfit, intuitively, the amount of valid segments would decrease. We find that there are the most valid candidates at the penalty value is 0.037. Now, the second step is to appropriately choose our distance thresholds. Firstly, we assume that the median distance in this distance distribution represents what should normally be acceptable for a near stationary state. The goal is to filter out segments which contain abnormally high distances from the segment mean, which cannot be considered within the stationary state, right? By the inspection of the above plots, we use the root mean square distance from the median of this distribution, as that's what we consider normal. As we decrease the so we start the threshold value and we start to lower it. Once the as the threshold value decreases initially, we would expect that the root mean square distance on average decreases as it's more conformal to the distribution. And once we start to overfit this threshold value, it would increase again as it's no longer conformal to our distribution. So this is sort of a correlation, if you will, to see how well everything conforms with the initial distribution. And visual inspection of these resulting plots indicates good outlier detection. The plot above is on the density axis. As you can see, it indicates the black bolded outlier indicates a change in the peak magnitude and time. So this cannot be considered a conformal with the rest of the curves. And the one below is from the flow axis and indicates a change in magnitude. So this indicates how our outlier detection method would be able to eliminate the outliers at the end. So in conclusion, this project establishes a framework to extend the concept of intraday stationary states to these week-to-week stationary states. It is automatic using our data-driven heuristics and minimal user intervention. And by utilizing the PELT method with the radial basis function kernel, it allows this method to detect underlying distribution changes in the flow and density of traffic. And by detecting and discarding these segments with anomalies, we can identify non-conformal days, which may indicate events, holidays, weather effects, accidents, etc. Thank you for listening. Do you have any questions?
Yes. Did you look at and treat flow and density as independent entities, or in your method were they viewed and modeled jointly?
So the way we did it was we applied yes, we treat them as somewhat independent agents. We applied the PELT method simultaneously to both of these, found the union of the change points, and we treated these as candidates.
Union of the change points across the two metrics.
Yes.
Okay, so in a way you did treat them jointly, at least in the out. Okay.
And besides the PELT method and the radial basis function, did you do a convergence test for those plots at all?
No, that's something do this further.
Okay, I was just curious.
So why would you take the union instead of the intersect of the flow and state? I was supposing that the stationary state means you have both flow and density staying constant. You're supposed to take the intersect.
The reason I chose the union was because, as I said, this project is an extension of a previous paper, the Yan paper from 2017. And during that within that paper, they used the PELT method simultaneously jointly on both and took the union. So it's an extension of that method.
By the way, Jerry is one of the original author of paper. So glad to meet you. He introduced this PELT method into our program. Yes, maybe you can ask him this question to get a better idea. Yeah, I think Jun, do you have some idea why not using just one variable? like speed, but using on both flow and density at the same time.
I think the reason is that they showed very different like patterns, even in the same days. I mean, flow rate is kind of bounded by capacity, but on the other hand, density is not bounded by capacity. So they show totally different patterns, even in the same day, the same traffic states. So we wanna see the different like kind of characteristic the same way we can, so that we can figure it out the week to week station state or correctly.
So when are we gonna hear if you proved or disproved the BPR function? What's the timeline?
Ladies and gentlemen, once we get the result, he will finish his PhD. Hopefully, it will be pretty soon.
Yeah.
No
Yeah,
pressure.
we do have some promising results. We do have some, yeah.
I have a question. How did you determine that the PELT algorithm was the most appropriate?
The reason we use the Pell algorithm was because as I stated, the original paper, the paper I was trying to extend from 2017 to what I was talking about, which had intraday stationary states. But I came across the Pell method when reading on methods of segmenting these multidimensional time series, but I also came across while reading that paper, and also came across the ruptures module in Python. It's a very useful module which the entire purpose of ruptures is to segment these time series. It's actually used by it's actually, I believe it's used by NASA in missions. So the Pell algorithm, it also operates in linear time. So that's.
And could I also ask, why did you use the RBF kernel instead of maybe a simpler distance metrics like Euclidean distance?
One of the biggest reasons was actually because the RBF kernel is roughly scale invariant. Within a lot of implementations of the radial basis function kernel, they have a bandwidth parameter. It's gamma, which is tuned based on the median of all the data you're trying to run it over. So it's scale invariant, so we can run the same penalty values over both flow and density.
Thank you.
So I know that you had a lot of challenges in this process. So could you explain what kind of challenges you had and how did you resolve it? Yeah.
Right. Initially, we were trying to use the LT Euclidean distance. Actually, I came to realize that since the absolute magnitudes of the flow and density curves are rather incomparable, it becomes difficult to fully realize that sort of joint analysis of flow and density if we use these. If we have to use different penalty values for the two curves. Yeah.
Well, thank you. I'd like to close with a final question. Alex, tell us what's next for you. What are your plans after graduation from high school?
Well, since I'm senior, I'm currently applying to college. I want to major in mathematics. I really enjoy statistics, especially sports analytics. I do a lot of college football stuff. Yeah. So we'll see how that pans out in the end.
Who's your team?
Texas A&M.
Okay. Why is Penn State so bad this year?
Oh, who's gonna win the World Series?
Well, that's baseball, but I really it's being Orange County, man. I really can't support the Dodgers.
Angels fan at heart. I appreciate that.
Go Hills.
I'll let that slide, Alex. So please join me in thanking my friend. I'd like to start with the high school student first, but I think he set the bar pretty high for the rest of you, so good luck following that. Professor Borowski, I'd like to invite you to introduce Natalia, and I should have asked Professor Jim, would you please introduce yourself and then a little bit, and then Professor Jim, when there's a moment. No, you.
Me first?
Yes.
Okay.
Uh-huh.
Oh, so I'm Professor Lisa Borowski. I'm an assistant professor here in transportation and ITS. My third year here. And I've had the honor of working with Natalia over the summer. I first met Natalia when she took my internship for equity class in the spring of 2024. So that was my first year here. And she did really well in the class, developed a survey, and I worked with her the following summer as she expanded that survey, looking at accessibility on UCI campus. And she presented that work at an international conference last spring. And then I was really excited to have an opportunity to work with her again this past summer And she helped us with a project that we recently got funded looking at accessibility among older African-American adults in Orange County. And that the co-PI on that project is Professor Sasha Volashina in mechanical engineering, so a very interdisciplinary project. And it was also the mentor on that project was my PhD student Mahabuba. So a lot of contributions here, but Natalia did an excellent job. I was really honored to work with her again. So thank you, Natalia, for all your hard work.
Thank you, Professor Broski. Can everybody hear me?
Yes.
Okay.
Or just- I think you'll have access to the slides, yeah.
Can I start to share my screen or do you prefer to run it here?
I can share my screen if that's
Okay.
easy.
Yeah,
Okay.
that's-
Okay.
While she's doing that, how about, Mr. J, you could introduce yourself.
Oh, yeah, okay, so I forgot, yeah. Yeah, my name is Wen Longqin, I'm professor in civil and environmental engineering and ITS, and I joined ITS in UCI as a faculty since 2008. And my research interest is in fundamental modeling of transportation systems, various systems, from cars to the network traffic flow. And I'm also interested in the management, planning, and of the transportation system.
Thank you.
Thank you.
Hey, Natalia,
Yes.
all yours.
Okay. Hi everyone, my name is Natalia Nagata. I'm a urban studies and environmental science and policy major at UC Irvine. And this summer I worked with Professor Broski and Mahbuba on a project called the Adoption of Mobility Care Plans Among African American Older Adults in Orange County. This summer I worked on the literature review and the survey design. And so I wanted to share some of the process and findings of that. So for the overview of our project, the context of our topic is based on the World Health Organization's Age-Friendly Cities Initiative, which was created in 2010. And basically they gave a set of guidelines on how social and physical infrastructure can support longevity among older adults in cities around the world. However, especially in the United States, we found that there's an intersectionality or a crossroads of oppression of infrastructure inequities, which creates barriers to longevity and fall prevention in some communities than others. And we have to remember that falling is an instant and leading cause of injury among older adults. And by restricting mobility, that can affect the quality of life for many people. And so our project aims to investigate the facilitators and barriers to physical activity and fall prevention among African American older adults who are 65 years old or older in Orange County. And we are going to do that by designing and conducting a survey that addresses multifaceted components of age-friendly communities. We're identifying factors that influence fall prevention plan adoption, and we want to improve community clinical linkages to reduce fall prevention barriers. So these are the 8 interconnected domains of urban life, which is created by the World Health Organization. And as you can see, said domains are community and healthcare, transportation, housing, social participation, outdoor spaces and buildings, social inclusion, civic participation and employment, and communication and information. And all of these factors they go hand in hand to create a better quality of life and longevity. For the literature review, I did, I guess, a more interdisciplinary research and tried to find sources from various fields, starting with how these age-friendly programs have affected different demographics. And some studies have found that these programs often center white older adults because it has limited outreach to racial and ethnic minorities. And there's also systemic influence such as economic insecurity and segregated spaces, as well as cultural mismatches that influence that fall short. And there's existing research that finds that non-Hispanic white older adults experience the highest fall-related deaths than Black and Hispanic older adults. However, in the United States especially, we have, once again, a history of segregation and under-resourced minority neighborhoods, and they experience heightened isolation, dementia risk, and health disparities, especially among older adults. And so we're trying to bridge that gap between the existing research and the existing data. And they find that spatial equity is crucial. And the frameworks outline measurable domains, but its success depends on locally led interventions that address both infrastructure and social connectedness. And I found some figures to give a more visual idea of our project. And so this model, this model is taken from a study that basically compared the, I guess, mobility change between different racial demographics. And basically they found that, they created this model that says all these factors like genetics, environment, and behavior can contribute to or influence disease, mobility, and adverse health outcomes. And this is the histogram about the fall-induced deaths among different demographics. And as you can see, the Black population tends to experience less deaths from falling than the white population, but they also have the worst experience with quality and access to healthcare. And we also wanted to explore the psychological theory. It's called the self-determination theory, which was coined by Ryan and Deci. And they're basically saying that autonomy, competence, and relatedness contribute to motivation and well-being. And so when you have supportive environments that can enhance these needs and unsupportive ones can hinder that engagement. And when we have structural inequities in infrastructure that can restrict choice, reduce perceived competence, and limited social connectedness. And that can reduce physical activity and fall prevention participation among those who are impacted. And autonomous motivation also can sustain health behaviors more than external pressure, but you also need competence and relatedness to help that. And by applying the social determination theory, we can structure fall prevention programs to support those three needs and boost motivation and well-being to overcome these infrastructure-related barriers to increase fall prevention adoption. So for our survey design, we used the Likert scale and open-ended questions because those are like the most accessible ways to assess what we're trying to find. And we're using 5 different categories. So that's health and wellness, outdoor spaces, social participation, transportation, and accessibility. And we drew some surveys from ARP and Dickin, and we are also using the questionnaires from the founders of the self-determination theory. They had a website that lets people use their questionnaires. So we're using their healthcare climate questionnaire and their perceived competence scale, specifically for physical activity and social inclusion. So this is what the surveys look like. So this is the ARP survey. This one just asks about social participation and inclusion. And they basically, they just ask like different components of how people might feel socially included or not. And we also have the Dickens survey right here on the left, and that is a more, it encompasses a broader scope of what the ARP questions cover, but we thought it would be useful because it's more concise. And on the top right, that's the perceived competence scale. And this example right here is for learning, but again, we're using it for physical activity and social inclusion. So questions might be like, on a scale of 1 to 7, how, I guess, how do you perceive your competence in terms of physical activity? And for the healthcare climate questionnaire, similar 1 to 7 scale, assessing how they perceive their healthcare climate. And for future work, we'll be collecting data in person in Santa Ana, and our project is in collaboration with Advocates for African American Elders. And we're going to do a statistical analysis of our survey data, and we're going to submit the paper to the Urban Studies Journal. And that's it. Thank you.
Thank you, Natalia. Questions?
May I ask one question?
Yes, of course.
I might got it right. I think on one slide you said non-Hispanic whites have a lower fall rates, but another slide said like a black, elderly people have a lower fall related death. Or did I get something wrong?
Yeah.
Was that kind of contradictory to me?
Yeah, so I think that's the literature I found that I thought was, I guess, interesting in the sense that so my literature review, like I'm trying to convey that despite existing research saying that Black or African American older adults, they tend to, I guess, experience fatalities less than white older adults. They also have like worse access and quality of healthcare. And I think that our project can address that, I guess, gap, and maybe we could see if we could bridge said gap.
So my memory was correct. You did say kind of like a higher fall rate, a lower death numbers. I mean rate numbers, I don't know exactly. And then also relatively worse, accessibility to health.
Yeah.
So that is a quite interesting. So I think what is going on. Thanks for the clarification.
Professor Finkel.
I have a question. So I'm not really familiar with the topic, but I'm kind of curious to know what are the characteristics of an age-friendly community or city?
Sorry, could you repeat the first part of the question?
Yes. So I would like to know what makes a city or a community age-friendly?
Yeah, so it's really dependent on the city, but typically we see things like walkability or bikeability and prioritizing, I guess, walking and biking and public transportation over car usage, and as well as I guess better maintenance with infrastructure so that, I guess surfaces of wherever people are walking are smoother and it can be accessed by everyone, as well as buildings, such as like I guess for here we have like the ADA compliances for buildings and how consistent that is. And if that's consistent throughout a city, then that could be a reason to call a city more age-friendly than others. I hope that answers your question.
Okay. I have just a follow-up question. Very simple question. Do you think like land use mixes can be also part of that characteristic of what makes a community friendly?
Sorry, could you repeat the first part again? Sorry.
Okay. So do you think that land use mix in a community is also something that can be characteristic of a friendly, age-friendly community or city?
Yes, I think the examples I just mentioned aren't just like the only criteria. There's definitely other factors that contribute to it because it's so multifaceted. But I think age-friendly cities is more about equity and like I guess we already have a set of frameworks to promote age friendliness, but then we also have to realize, I guess, the historical context of these areas and how that might prevent age friendliness in a city.
Okay, thank you.
And Dr. Franco, could I ask you to introduce yourself? We've introduced faculty throughout the
Okay.
event and you.
So,
Here.
so my name is Sophia, and I'm a urban economist, but I also work on transportation related topics. So anything that is related with cities interests me. So, and I come from the economics department here at UCI.
I might just add maybe one detail to what Natalia just answered, if that's okay. Yeah, Natalia answered that really well, but I was just gonna also emphasize that it was really hard to answer because I think she showed like a slide with the 8 different dimensions of age-friendly cities, and each one of those dimensions has the existing surveys probably have like 20 different indicators of each one of those dimensions. So the surveys that they use are very, very long, like hundreds and hundreds of questions just to measure is a city age-friendly. And so one of the things we're doing also is working with our community partner to update those questions to make sure that they're culturally relevant for the African American community. So it's a long process why we don't have results yet, but we're just like updating the tools just to collect the data.
I have a question for Natalia, and I'll go ahead and introduce myself. I'm Victoria de Guzman, and I lead programs and engagement here at UCI. And it's my pleasure to have led this program. Thank you all again for your support. Natalia, have you thought about ways to make this survey more accessible to older adults?
Yeah, so I think one thing we're trying to implement is to just make it as concise as possible while trying to cover as broad of a scope as we can because like Professor Borowski said, assessing these things is like very comprehensive. And so we're working to see like which would be, I guess, the most optimal questions. And of course, like I guess the visual of the survey would be more accessible. We would probably like make the words bigger and more bolded with a more accessible font so that it's easier to read through. And yeah, yeah.
Thank you so much. Are there any other questions? Well, congratulations, Natalia. Thank you for a fantastic.
Thank you.
Professor Wang will introduce student Alex Bergman, and I'd like to point out that Alex is groundbreaking in a really interesting way. This is the first time we have had a non-UCI undergraduate, not only in the program, but on payroll. So we want to thank him very much for jumping into UCI. Yeah, maybe you can introduce yourself and then help us out.
Hello, everyone. My name is Professor Quinn. I'm from the Mechanical and Aerospace Engineering Department and an ITS affiliate. My role comes in since my research is focused on civil air transportation. So diverging from ground transportation, we do a lot of research looking at flight operations as well as how to make the air transportation system as a whole more sustainable. And recently, our lab has been doing a lot of work in the development of flight operations for advanced air mobility, which actually requires a lot of work because unlike legacy air transportation, there aren't currently advanced air mobility vehicles flying, which means that we have to develop how we model and assess the vehicles ourselves, as well as have to look at what types of operations could be possible. And this is leading into a lot of work that my grad student Melissa is currently doing, where we are trying to assess how communities may be impacted or may respond to an eventual advanced air mobility implementation. So in order to really look into those research aspects, there's various different pieces that come into the puzzle. So one of them is going to be some of this work that Alex is presenting today, which is on compiling barriers in advanced air mobility implementation. This has to do with the in-air side of things. So if you want to design an operation, how is it going to work when you are moving this into a already existing transportation system? And then we'll get into some other topics later, but I think we'll start with Alex for today, or right now, and then we'll go forward. So, yeah.
So, good morning, everyone. I'm Alex Bergman. I'm a fifth-year aerospace engineering student down at San Diego State. And of course, as Professor Wang mentioned, I was working on compiling barriers in advanced air mobility integration with her, along with Vika and Melissa this summer. There we go. So for a brief table of contents, so first I'm going to introduce the topic and then present my work, and then I'll have some closing thoughts and reference work. So first of all, what exactly is urban air mobility? So urban air mobility is the subset of advanced air mobility, and specifically defined here by the Federal Aviation Administration as enabling highly automated cooperative passenger or cargo air transportation services in and around urban areas. Take Southern California, for example. And for our case study, the primary purpose was to alleviate traffic congestion using eVTOL, which stands for Electric Vertical Takeoff and Landing Aircraft, which I have a photo I'll show in a moment. Because of course, I mean, we've all driven on the 405. We know how bad the traffic can get. And then some examples of some current front runners in this brand new topic is Joby Aviation. And they have actually just signed a partnership about 2.5, 3 years ago with Delta to provide Joby air taxi services in between the downtowns of their major hub cities. And the first two of these cities will be Los Angeles and New York, as those are some of their largest bases. And according to Joby's CEO, a flight on these Joby aircraft from downtown Manhattan to JFK should take about 7 minutes compared to 50 to an hour and 15 minutes to actually drive in a taxi or an Uber. And also Joby has additionally entered into an exclusive 6-year agreement in Dubai to operate air taxi services. So first of all, here's a kind of a rudimentary diagram of UAM and AAM operations. So up here, we actually have these UAM vehicles, and then up here is the legacy traffic, which I'll talk a bit more about in a moment. And then we have the the rural, suburban, and urban. And the idea is to have, these UAM vehicles, they will take off from a vertiport, which is basically like a helipad with like a Tesla supercharger on it, so they can charge these vehicles, and they'll take off and they'll enter these designated corridors. That way they're above general aviation traffic and then below legacy traffic, and then fly to wherever they need to go. And then this one right here is a more advanced one. And there's two distinct corridors, both going in the same direction, because this one is kind of to act like a transition, so vehicles can enter and exit the corridor. And then the one here on the top is just for like express. So if they're like, if they take off from example, this vertiport on this farm, and they're going all the way to the city, they can, take off, climb up here, and then actually fly, without having to worry about traffic coming in here and interfering with them. And then here's, so UAM, as I mentioned, is split between both cargo and passenger operations. So just a brief example of a cargo one. This is it's a full drone that's being designed by Boeing. And then here is the actual sort of vehicle that will be used for these air taxi services. This is Joby's S4, which is their most current model that they're developing. All right, so as we all know, may or may not know, the skies of Southern California is some of the most congested airspace in the world. And of course, we all know about congestion living here in Southern California. There's traffic everywhere and people everywhere. And then as such, these UAM routes, they have to be carefully planned in order to not interfere with so-called legacy traffic, which Professor Nguyen mentioned briefly earlier. And that is just pre-existing pilot-controlled aircraft. So think of, your average American Airlines flight, for example, or UPS cargo flight. So, and then the three main ways for the UAM flights to avoid interfering with this legacy traffic is to either fly above it, fly below it, or just avoid it entirely. But because arrival and departure procedures are different at different airports because their runway configurations are different, UAM route planners need to have they need to have access to some kind of tool so they can actually, visually see where these excuse me, the legacy traffic patterns are going. That way, they can plan accordingly. And that was my primary task, was to develop a preliminary tool that we can use to model legacy traffic patterns into airports. Sorry about that. So implementation. So the case study that we chose to analyze for the summer was just a basic route along the 405 between right next door here at John Wayne Airport and then Long Beach Airport. And we're using ADS-B positional flight data from OpenSky's network. And this ADS-B data is all aircraft are equipped with a transponder, and that provides signals to air traffic control about the speed, the heading, and the position of the airplane. So we're taking that data that was collected and there's various receivers everywhere, including obviously airports. And that's where we're getting the data from. And then these were processed through both Python and MATLAB. So I could develop a 3D model to map the arrival procedures at John Wayne and Long Beach airports, so that if a route planner was to be designing a route between these two airports, they would know where traffic is and where it's not. All right, so let me go through these one by one. So first of all, up here on the top left, this is they're called flight tracks. These lines here represent arriving aircraft into John Wayne. And as you can kind of see, they're coming from kind of two different directions. So down here towards the bottom right, they're coming in from like the Bay Area and stuff. And then these ones are coming in from like other areas like Chicago or Phoenix, for example. But as you can see, they all kind of follow this yellow reference path that I was able to draw. And they all kind of come into these rectangles, which we're calling as containment zones. That way, so they're in as concentrated an area as possible. That way the UAM route planners can actually visually see, where they can fly and where they cannot. And then down here, it's just a zoomed in feature. Would be classified on short final. So within, less than 500 feet before the runway, the tracks come in. And then of course they end right here at the end of the runway. And then here's one for Long Beach. There's not as many tracks on the Long Beach one because, funnily enough, the data I took was from April 1st and April 2nd of 2024. And I think they pulled some kind of April Fool's reverse trick on me. So normally the arriving runway is runway 30 at Long Beach, but I believe on April 1st, they had to, because of weather or whatever else, they had to reverse operations. They were coming in and landing from the north instead of from, excuse me, the northwest instead of the southeast as typical. So, and that's what these, I know it's kind of hard to see, but these darkish blue tracks, these are representing, I believe, go-arounds, and then they came around to do the actual reverse procedure. And then, of course, this one is just a zoomed-in representation of the wire, these rectangles, and again, with that yellow reference path. So in conclusion, because this concept is in such an infancy, there's plenty of other boundaries that need to be considered. But of course, I chose to specifically focus on actually, mapping these legacy corridors, because that is arguably the most important, because this is what the FAA needs to see, as evidence to prove that these UAM vehicles can operate safely and efficiently without, interfering with legacy traffic, which of course, we don't want to end up in the hands of lawyers and everybody else. So, and of course, tools like this, the one I've been developing, they need to obviously, continue to be approved. As I mentioned, this is a very preliminary tool. And of course, the idea is to develop it so, there's access to all airports, and all specific arrival procedures. That way these UAM route planners can account for everything. And then of course, once they do that, they'll be able to, UAM operations will be able to, get off the ground. And that's all I have. Any questions?
Okay, so just out of curiosity, how much does it cost? You know, a trip, let's say from downtown to a major airport for a passenger?
Well, that was actually not my specific area of focus, and in fact, Vika is actually gonna be talking about that. So, she will be able to answer that question.
I think I have a question that was on your side. Besides airports, what would other no-fly zones be?
So that would have to be determined through community outreach, and that's one thing I should have mentioned. But again, I primarily focus on airports because that's arguably the biggest hurdle, but then it would be the companies working with communities to actually establish, if, specific altitude or noise restrictions, like for example, at John Wayne, there's the noise restriction, no takeoffs or landings after 10 PM. So yeah, they would have to work on that.
And a follow-up, I'm thinking about other areas. Would the tools you developed also work in suburban, rural areas?
Yes. And I should have also mentioned that I didn't really consider general aviation, even though there's a lot of it here in Southern California. I didn't consider it for my models because it's not as predictable. Because with general aviation, you can get in your airplane, take off, and do whatever you want, whenever you want. So, but yes, you could do it because they have even general aviation has those transponders that transmit the information. So just be changing the lat long areas where the data is being processed, and then you could adapt that accordingly.
This question is kind of related with the first one, but you mentioned during your presentation that this type of urban mobility can be a tool to sort of kind of go around the problem of traffic congestion.
Yes.
Right? How do you think this is going to work as an alternative to travel by car?
Well, I mean, like I mentioned at the beginning with Joby and Delta having that air taxi partnership, because well, I don't know if any of you have been to JFK, but it takes a long time. I mean, even here to LAX, it takes a long time to first of all, you have to get off the plane, get your luggage, and then get outside. And then if you're going all the way downtown, and let's say it's like a busy Friday night, traffic on the 405 or the 105 or whatever is super impacted. So it'll take you a lot longer to get where you need to go. Whereas you could just if you have the cash, you could pay a little bit more and take these air taxi services and then get there and get there faster and get to downtown much faster.
But when you mean by a tool that can be a possible solution to traffic congestion, you mean kind of for certain groups in the market, this can be an alternative travel mode,
Yes.
right? This will not really be a solution for traffic congestion.
At least right now, because again, this concept is in such its infancy. We don't exactly know how pricing is going to work. And again, Vika is going to talk about that shortly. But yeah, for right now, it's I would say it's probably out of reach for most consumers. But of course, as operations continue and there's more capacity added, then of course costs will go down.
Just curious about the prototype you mentioned. Is this meant for short-term distances?
Yes, it is. So I believe, from what I remember correctly, the Joby S4, its maximum range is about 150 miles. So it could do, I mean, theoretically, John Wayne to Long Beach is I'd say about 25 miles. So it could do probably, 4 trips before it needs to be fully recharged.
Yeah, because I was just wondering, like, if it would be able to go from like Southern California all the way to like Northern California.
Unfortunately not. That would probably have to be on a system of them, but of course, we'll have to see how that develops because, these are just, short range vehicles, but of course, long range vehicles could be developed in the future.
Thanks for the presentation. I probably have some comments related to the previous 2 questions. Maybe a little bit of background about me because so my name is Wang. I'm currently a PhD student from Munich in Germany. And actually we did this kind of more choice or like market research in Germany regarding the UAM, but not only for the urban, but also intercity, so long distance ones. And what we realized from the result is, okay, so I totally agree with the like flight time will be definitely shorter than if you are congested in traffic. But the problem is if you drive, it's door to door, right? And if you use UAV, so first you need to drive, like you either drive your car or like use public transit to go to like a vertical point or like an airport. And there is access time, and you probably needs also like processing time to like getting board into or even security check like normal flight. And then also need to consider the like egress time.
Yep.
So probably from our results for long distance, it's really didn't work out in Germany because if you drive, you probably save like more time. So I think like, I mean, I agree. I know you are working on the implementation part, but maybe it's also very interesting to look at whether is it really like a market existing there? Because if it's not saving time and even it's more expensive than driving, it could be very tricky, right?
Anybody else?
Okay, and I have one question. I think you later touch upon the safety. So is there any kind of safety standard for this kind of thing? We know that helicopter can be very dangerous, right?
Mhm.
Yeah, just twice as fast, I associate as cars, but they are at least 10 times more fatal
Mhm.
than cars. So I'm wondering for this UAM, what do you guys have a safety standards, for example, fatality rate per million hours of flying? For cars, it's just one fatality
Mhm.
per million. I mean, for this one, is it kind of standard or any target for this?
I mean, obviously, not that I particularly focused on, but obviously it would be within margins set by the FAA. And of course, I should have mentioned these Joby aircraft, they're not fully autonomous. They actually are piloted aircraft. So that, and I believe because of the altitudes they'll fly at, which is below 5,000 feet, they'll be observing visual flight rules. But then again, they'll still have transponders, so air traffic controls will know roughly where these airplanes are, operating. And of course, with visual flight rules, pilots are required to, they may receive traffic advisories from air traffic control, and then they have to look for the aircraft and then report that they have the traffic in sight.
So if I remember correctly, fly a little bit higher than helicopter, right?
Yes, they can. Yes.
Yeah. So I'm wondering how it's comparable to helicopter safety record. It said helicopter is at least 10 times more dangerous than cars. Yeah, so I think that would be a big question to get the general public's trust, right?
Right.
In the technology, in addition to the efficiency issue.
And of course, I would assume that they would start out with like pilots who have helicopter license, but of course, I think additional pre-qualifications will need to be implemented because the Joby S4 is kind of if you notice the rotors are kind of they rotate up, kind of like the military transport, the M22 Osprey. And obviously, I don't know the specifics of the training, but I would assume the Osprey pilots receive more specific training. So certain procedures like that would need to be taught to these the pilots flying these sort of vehicles.
I mean, for this is not just to this one. So aviation. I mean, whatever accident tend to be fatal.
Right.
Not like on the road.
And of course, that's going to come with actual. Well, unfortunately, the consequences that's going to have to come with operations and and actual in testing in the field. So that would have to be determined. And I should mention when I was reading the FAA report, including the one where I pulled that definition of UAM from, the wording is very loose because the FAA, because none of these are in widespread operation yet. The FAA doesn't know exactly how it's going to work. I mean, they have some previous guidelines from commercial helicopter and airline operations. But other than that, they just are not entirely sure how exactly it's going to work. So the term, the wording is very loose, and of course, with time, they'll change everything.
Thank you.
As I said with the high school student, UCI students, I think Alex just set a new bar for to keep up with him. And thank you very much.
Thank you. Go Tex, baby.
So Luke, you are to follow, and Professor Byron, could you also introduce yourself?
Sure. Hi, everyone. Mike Hyland, assistant professor here in Civil and Environmental Engineering. My research is on transportation modeling and analysis, and to focus on innovations in the transportation space, particularly on the service side, so like Uber and Lyft, how to operate those services efficiently, but then also try to understand their impacts on society. So connecting people to jobs, healthcare, food, groceries. It's also trying to minimize the negative externalities of transportation. So I'm happy to introduce Luke here, who I guess similar to Professor Hyun's projects, is one of many researchers on several projects related to microtransit. I don't know how much background you have, but I guess I'll provide a little myself. Microtransit is similar to Uber and Lyft, except it's owned by transit agencies. Tends to involve large vans, very small buses, serving groups of travelers at a time. So my group is trying to understand where these microtransit services should operate. Probably not in downtown areas where existing fixed route transit is providing good quality service. Probably not in very wealthy areas where people have access to cars, but maybe in suburban low-income areas, it's kind of potentially the hotspot. So I think Luke will tell you about his interesting work. Let me just say, been a great part of the research team these last 5 months. His computer science background, he learned the lack of ability of myself and many civil engineering students when it comes to programming and software development. So he's been a big help in this area. So please join me in welcoming Luke.
Thank you, Professor Highland. Hi, my name is Luke. I'm a third-year applied math and field performance major, and my topic today will be clustering and optimizing transit requests for scalable shortest path solving. Thank you. Today we'll just be talking briefly. We have 4 topics today. We have the basic problem I'm trying to solve, my proposed solution, the results I got, and the further improvements I can make on my solution. So the basic problem is that our system currently is agent-based. So like in Google Maps, let's say you're trying to find the shortest path from the arc to the park. As an agent, you're sending in a request to go from the arc to the park, and then the algorithm will generate a shortest path based off of many different factors. Generally speaking, usually most pathfinding algorithms are pretty simple, taking into a couple of things. However, ours is multimodal, which means it takes into account things like link type, which include like walking, biking, but fixed route transit, microtransit, others like that. Time of day, so it takes into account surges in traffic, and various factors like that. Due to the amount of agents we have, in terms of our network that we run on, we have around 1,000 nodes, 3,000 edges for this graph, and there's a few hundred agents. We want to make sure that this algorithm was fast even for a significantly higher amount of agents. So the goal was to cut down the iteration time by a significant margin, because every simulation we were running took like 5 to 10 minutes when I first started it. So initially, we ran a multimodal Dijkstra. Dijkstra, as you can see, is a shortest path algorithm. It just kind of systematically explores every node and updates the weights so that at the end, you'll have the shortest path to every single node. So what we did was that we took into account every single value that affected the time, such as count, cost, time, and link type. We thought it would be a lot more efficient to kind of cluster these agents instead of handling these requests one by one. And then so my implementation is that I use k-means clustering to cluster agents by their sensitivity to travel costs and their time. If you can infer a lower travel time, a higher sensitivity to lower travel time implies a greater preference towards cars, because cars are generally the fastest way of travel. Then you would profile every cluster by that, and we would create like kind of a cluster profile, because we inferred that if similar agents have similar sensitivities to cost and travel time, then they will have similar attributes across all other things, like how much they're willing to pay and wait for microtransit and other factors like that. And then for each cluster, we would run Dijkstra from every source to every other node. So it'd be a source to all Dijkstra repeated across every single source. And then after that, we would look across every single agent request. And for every origin, you look what cluster they're in, and you pull like kind of a dictionary of the path that would be optimal, as well as other factors like cost and time. The results were not very pretty. It was actually slower than the old algorithm. I suspect because we didn't have a lot of agents in our example simulation scenarios, so that a lot of the node search was actually like not populated. So let's say we have 1,000 nodes, right, and we have 500 agents. At most, you would be looking at like 500 node to node, like origin to destination pairs. However, if you run all sources to all nodes, there's around like you have 1,000 origins and 1,000 destinations. There's like 1,000,000 different routes you can possibly take. So a lot of these end up being unexplored, and as a result, this kind of clustering makes more sense when you have a lot of agents, like on the scale of Google Maps, where you have maybe like millions of requests to that service, and you need to be able to handle all of these effectively. However, due to this current runtime issue where we are using a network X implementation of this graph, so a lot of it is the backend is using Python. So it's very, very slow because a lot of it's high level. You have dynamic types you have to work with, and yeah, this will be tried. I'm going to be working on improving this in further work. So a major improvement I'm seeing is instead of holding the network X graph in just using the graph and converting it to a set, I was considering converting it into a PyGraph BLAF adjacency matrix to hold this data. The reason being PyGraph BLAS is actually only ran with Python 3.7, which eliminates the other interface, and it's based in C, and it's designed for large sparse graphs and parallelized matrix computations. So this allows us to explore different parallelized algorithms that lend itself to large sparse graphs, like Johnson's algorithm and delta stepping. And I will be working on implementing this in the future. And to give a better explanation of what PyGraph BLAS is one of two interfaces that runs on the Graph BLAS library written in C. It's written by some researchers at MIT, and it's mainly used to allow its website says it's like a building block to a lot of graph algorithms, and they just want to kind of make it uniform for non-technical researchers to kind of get their graph algorithms up and running very quick instead of getting down into like performance implications. Yeah. And a lot of the external work done outside of the algorithm. This was a very large code base. When I opened it up, it was a 8 GB zip file. So I kind of separated the CSVs and created a GitHub repo. And I'm using it right now. I hope many of my team members can learn to use it as well. And I've been also I think a good month was spent on just fixing hard-coded file references. So now a lot of the work is a lot more accessible. Just the locations are based off the location of the file you're running. So yeah. Thank you so much. Any questions?
Yes.
Thanks for the presentation, very clear structure, I really like it. I'm just thinking about the use case. So besides like trying to accelerating the algorithm itself, since you mentioned like this like a clustering method only works when you have like a really large amount of requests at the same time, right? Does it make sense to do it like, I don't know, like offline? So once, for example, you just pre-calculate everything offline. So let's say if it's microtransit, you can calculate for all the microtransit data for the past months, and you have this like pre-calculated timetable, and based on that, you do the real-time calculation for each single individual request. Then you don't have to. Yeah.
Right. That's a good question. I think depending on where the travel areas are, this data would be pretty hard to calculate, just considering the scale that you'd be doing. If you're restricting to just like one steady area, like we did downtown SD and Lemon Grove, is the files I was working on. I don't think that would be too much of an issue, but if we extend this to larger study areas like the wider Bay Area or wider LA, I can imagine how complicated it would be. But it is possible. I just haven't really looked into it truthfully. But yeah, good question. Thank you.
Because now you're doing it online, right? So you're doing it on real time.
Not entirely sure. We get submitted a network X graph, which is like static.
Yeah.
So I think if the file changes, then the results would be different. I'm not sure if we're updating this file real time, or I'm not entirely sure what's going on with that, and I'll be honest.
I wouldn't say it's real time. We're trying to find the equilibrium between the mode choice and the performance of the microtransit. So we're using an iterative method. And what changes from iteration to iteration is the microtransit wait times and the microtransit detour times. So when those change, you have to update the whole graph and then resolve the pathfinding. So historical data is not that helpful here because we're changing the graph.
I had a quick one. You explained you have a new method and why, but I noticed that the accuracy dropped. Have you thought about why that might be?
Yeah, I believe it's because we're doing a cluster profile. So we're profiling every single cluster into like a few subgroups. I'm using a silhouette score method and kind of evaluating to find the best amount of clusters to run in. But generally speaking, cluster profiles will typically generalize a profile of like a specific like amount of agents. And so these requests will be kind of catered towards minimizing the travel time for all these agents within the cluster and not just for specifically not for a specific agent. So across the cluster, it will be more efficient, but for individual agents making these requests, it will be a little slower.
Can you compare the paths of between the two methods?
Not particularly. What I did was I ran a simulation. It was like the run examples in pi, and I just kind of compared the metrics, and that's where I pulled the numbers from. I'll probably, once the algorithm works a little better, I'll probably look at the paths itself and see how it's working. But yeah, it's probably something to look forward to in the future.
I know I speak for all of us when I say we look forward to your continued work and congratulate you on your research. Thank you.
I do.
Of course you do.
Yeah. So, I mean, the current, the algorithm use the distance, travel time, maybe cost into the optimization. I'm wondering, is it possible to incorporate some like personal preferences on routes, the type of roads into the algorithm? Because that's my kind of driving experience, right? I mean, many times I prefer freeways than the local streets and things like that. I'm wondering if you considering this or.
Right, that's a really good question, actually. Short answer is yes. I believe in a network X graph, what we're doing is we're importing the agent nodes, and we're kind of just seeing there's a bunch of different weights for how much one weights like microtransit, like the cost of microtransit, and like how much they would prefer to be on microtransit, how much they'd prefer to be on fixed route, cars, and all of that. The tricky thing is how we're gonna get them to input that information in a easier manner. We haven't really designed the interface to this yet, but we are taking into consideration. And when I mentioned clustering, when we're clustering by sensitivity to travel time and cost, after we're doing that, we're doing the clustering profile, and we're taking the Euclidean mean of all these weights towards these like preferences towards microtransit times costs and all these other factors.
And maybe for that, I'm using a large language models and this can be helpful.
Maybe.
Yeah,
I think it would be helpful, maybe.
chat with a little bit with your customers.
It could be used to kind of parse and kind of decipher, like, let's say someone doesn't want to enter in all that like technical, like how much weight, like would you put like 0.2 or 0.6 weight on how much you would want microtransit, you could kind of get an estimate based off of someone's like description, like you can ask them to describe what type of transportation experience they would want, and you could kind of decipher what their weights would be based on that.
Yeah, I think that would be very valuable. Thank you.
And kind of jumping on the back of that question, you gave me an idea. You have the travel time, you have the travel cost. And I think especially it's important for micro transit, but it could be important for all types of transit. I mean, depending on the mode, are more or less important, right? But what if you looked at like publicly available crime statistics with like violent crime and like property crime or something? And then you created like a safety index for links. And then that should probably be an important variable, like equal to cost and equal to time, because especially if you're on public transit or micro transit, you might like want to avoid taking a certain corridor or certain link if you have a higher likelihood of experiencing like a crime event. You know, like I would rather take a 5-minute detour than going through there, for example, right?
That's cool. That's something we haven't really looked into a lot. I think the main roadblock to that would be kind of data availability, but I'm sure that is not super hard to find. As of in terms of equal weight, I think we can also let them set a preference for how much you want safety to be weighted.
Yeah.
Like I remember I went to see a concert in LA and I accidentally walked through like 10 minutes of LA's fashion district on foot at night. I didn't mind it as much as I thought I would. So depending on a user's tolerance to safety, you can kind of adjust that as well. But that's, as you mentioned, you can kind of adjust that and kind of interpret that from like maybe like a large language model if you don't want to specify that at all.
Yeah, good idea. Right now, the pathfinding is agent-based, individual-based, so adding attributes is fine, we can just add a bunch and solve that. But if we do go with a clustering approach, the more attributes you're using to classify people, the more clusters you're gonna have, which will slow down the second approach.
Yeah, and I think also the more adding on to that, I think the more attributes you have, the biggest flaw I see with this clustering system is like, let's say everybody has very different tolerances and requests and it's like unable to cluster, then these clusters by themselves will not be very accurate.
Right.
I'm still looking into a solution to that, but it might be just kind of switching between like a cluster base and just the standard agent origin to destination individual base.
Well, thank you, Professor Jin, for starting a really interesting conversation for us. He always has the best questions. Thank you, Luke, very much. Yes, now we have Saathvika, who has been queued up with questions even before she starts.
Do a very reintroduction. So thank you, Alex, for presenting. As we had mentioned, we're doing research into what requires a lot of different pieces of the system. And we talked a bit about safety. We talked about cost and pricing. Alex was presenting on air taxi potential restrictions, at least in the air. And this is really because we are trying to systematically back out and determine what routes may be possible in a given area for air taxi implementation. But this other question that we're working on here today, and this is now looking into the community aspects of advanced air mobility implementation, is assuming you do have routes and assuming they're safe and assuming they work in the current airspace system, is now what kind of possible accessibility questions do particular route to bring up. And so this now brings us into Vika's work today, which is our attempt to answer what some of the potential questions we may have as far as community accessibility would have when you implement a particular system for advanced air mobility. So I'll let you take it away. We can see what kind of questions we can answer.
Hello everyone, my name is Saathvika Ajith, and I'm a second year aerospace major at UCI. And this is Community Knowledge Exchange for Future Air Taxi Innovation. So, I have a few concept pictures of said air taxis up on the slide. So, every day we step closer to the sci-fi author's dream of flying cars becoming a standard mode of transport in the 21st century. Currently, several aviation companies are leading the charge in developing all-electric vehicles designed to make fast, short hops within or between major cities and existing airports. When they're launched, we'll know them as air taxis. But it's not enough to design and execute the mechanical aspects of these urban air vehicles, or UAVs, in order to release them to the public. For their seamless integration into everyday life, infrastructure and policies are just as important. There are many factors to consider and regulate, such as UAV noise, carbon emissions, energy consumption, cost of operation, for both the comfort and safety of the public and the continued growth of the budding air taxi industry. In order to maximally avoid scenarios like UAVs flying low over residential neighborhoods or ticket prices rising to exorbitant and unaffordable levels, air taxi routes must be carefully pre-planned and optimized, compared and contrasted for factors such as ticket price, energy consumption, and no-fly zones, with a focus on being the least disruptive and most additive to public life. In order to investigate the impacts of future air taxi innovation and more easily communicate my findings to impacted communities, I used MATLAB to develop a model to graph prospective air taxi routes onto a map of the Irvine area and calculate important factors for consideration, like distance, energy, and cost of flight. The map has an adjustable zoom, and the user input is in the form of clickable or typable waypoints that the UAV will fly over. In its path. The user can also adjust the altitude of each waypoint to mimic takeoff and landing for more precise estimates, and there is an optional flight animation in the perspective of the air taxi to get a better idea of the path and any obstacles that might be on it. I wanted this model to be equally accessible to researchers judging the efficiency of a flight path and communities that want to become more informed on the functionality and limitations of air taxi flight. The bulk of my model's usage is not in graphing the flight path, but in calculating the energy and cost consumption of the UAV on the selected route. In that vein, the two major components of my work that I'm going to discuss today are the energy model and the cost model. To make more accurate predictions, the program needs a few specifications on the type of air taxi being considered for the flight. Mass, speed, purchase price, and passenger capacity are some of the required parameters. The baseline estimates you see in the model today, by default, are based on the prototype Joby S4 electric takeoff and landing vehicle, which is the most advanced UAV prototype from Joby, a current leader in the industry and partnered with NASA to further urban air mobility. From the distance data derived from user inputs from the inputted flight path, the first calculation made is the estimated energy required for the flight. The energy model takes the predicted power-to-weight ratio of a standard mid-size multi-rotor 4-passenger electric air taxi, as well as its mass to calculate the base power used to run the motors and engine. Then its cruise speed is taken into account, so if the UAV ever goes above a set reference speed, then the effects of drag on the UAV are increased, so more power is consumed to compensate. Additionally, energy consumed while taking off, landing, as well as the avionics, lighting, and environmental control systems is added to this total. From there, the total flight time enables us to predict the overall energy consumed in the flight, and with a cost of 30 cents per kilowatt hours of electricity, we also get a final energy price estimate. There are many factors that influence the cost of operation, and therefore ticket price of an air taxi flight, no matter how quick or short it is. The most expensive of which is the energy consumed, calculated previously, but this value is closely followed by capital costs of the UAV, things like infrastructure, insurance, and part replacement costs. In my cost model, large upfront costs are split apart and paid essentially hour by hour over the duration of the UAV's flight life. A safe prediction for a UAV is to average up to 10,000 hours of flight before it needs to be retired. So every hour the UAV flies, there's a set base price, so investments into it can eventually be paid off. There's also a set price for an air taxi flight regardless of path length, due to costs incurred during ground time, the periods preparing the UAV for launch and ensuring its safe landing. Another essential aspect is crew and maintenance costs. Higher salaries will be required for the specialized personnel required to pilot the UAV during flight, guide it during taxi, and repair it during maintenance. Additional maintenance costs are incurred during mandatory yearly checkups and parts overhauls every few years to ensure the UAV's smooth running. Slightly more difficult to model are the indirect costs, such as marketing fees or hangar infrastructure, that can be reliably estimated at around 25% of the direct costs. Taxes would increase overall costs by another 10% at minimum. The final ticket price predicted by the cost model depends on the capacity of the UAV, which is then divided evenly between the operating cost, as well as priced up by 25% so the air taxi service can make a profit. This standardization makes it simple to compare and contrast different flight routes with the consideration of how much a customer would be willing to pay for the trip. There's a video right here. Now for the application of the flight path route model. I have a video demo of MATLAB where I'll chart out a short UAV flight over the Irvine area. Still pictures of the model, but this would be how it looks. There's a little animation, but either way, based on current predictions on UAV infrastructure, the flight will be between the existing Long Beach and John Wayne airports. Prime locations for adding UAV vertiports required to launch and land air taxis. The UAV will not take a direct path between them, instead sticking closely to existing highways so there will be minimal disruption to surrounding communities, flying at a standard altitude of 2,000 meters. On the left-hand side of the model, you can see that there's a 2D map of Irvine with a data tip that would follow the location of the UAV on the path and give you values such as its altitude and longitude and latitude. On the right-hand side, the UAV's route is plotted on a 3D satellite map, and the camera angle will follow the air taxi and what it would see on the flight. Finally, we have the calculations made by the energy and cost models displayed in the command window. You can see the flight took around 8 minutes, and accounting for ground time, in which the air taxi prepares to launch and land, passengers spent 38 minutes in the UAV. The flight covered 32 kilometers, consumed 957 kilowatt hours of electricity, and had a total cost of $872. The predicted passenger ticket price is $290, and normalized for distance, the passenger is expected to pay $9 for every kilometer flown. Next, we have a medium-length flight from UC Irvine to LAX. While UCI currently doesn't have the necessary infrastructure for a vertiport, this is a good example of a medium-distance flight that would garner a lot of community interest and would likely be in high demand. It's a 15-minute flight that covers 65 kilometers, has a total cost of $1,390, and despite being twice the length of the previous route, the passengers paid $390 per ticket, only $100 more than the shorter flight, and have a lower kilometer flown cost of $6, as the high base cost of launching an air taxi are spread out through a longer distance. Here we can see how the waypoints would look that our user inputs. You can click them on the map, or you can also type them in by longitude and latitude. At a distance of around 180 kilometers, the flight between LA and San Diego airports is over current UAV flight limits and would require refueling the vehicle at in-between stops or future advancements in technology to achieve. This route is an example of a cross-city flight that would be appealing to frequent travelers. What would be a 4-hour drive, accounting for ever-present traffic, would take a UAV just 43 minutes of flight. With over $3,000 of total cost, passengers would be paying $1,076 per ticket, however, just $6 per kilometer, much like the the medium length flight. Here I have a quick overall comparison of passenger costs for the three distance cases that I mentioned, both with each other and with how much it would cost to take an existing ground taxi service such as Uber or Lyft. The overall trend between the flight is that it's more cost effective in terms of price per kilometer to take longer flights as the energy consumed is a standard rate and the high base costs of flying in a UAV are spread over a greater distance. Compared to ground taxis, UAV trips are more expensive, ranging from 1.5 to 2 times the cost, but make up the difference in speed. The time consumed for air taxi trips ranges from a third to a fourth of the time taken by an Uber, with the difference being even greater if ground traffic is taken into consideration. With successful test flights being completed as recently as last month, it's clear that the advancement of urban air mobility will soon progress past its current contained sphere and start affecting day-to-day life. The objective of my research is not only to investigate the nature and impacts of UAVs becoming standard public transport, but for this important information to be easily digestible to those curious on how their life may be affected as well. This tool is a piece of a grander framework on communicating the impacts of urban air mobility, one that we can use to better gauge the public reception to air taxis, one of the current blind spots in the industry and a crucial factor for these vehicles' seamless and successful integration. Though they may look different from anything we've previously imagined for flying public transportation, air taxis are charged to become an enduring aspect of public life, and it's our responsibility to ensure these changes are enacted purposefully to bring the maximum utility and benefit they can without conflicting with traditional aviation and community needs. Thank you so much to my mentors and advisors, Professor Quinn, Melissa, and Miss Victoria. I wouldn't have been able to succeed without the opportunities and guidance from these incredible people.
So this was really interesting. I have two questions. The first one is I didn't understand exactly how did you translate the total cost flight into the costs, the ticket price per passenger. How did you go from that?
Okay, so the total cost of the flight is made up of a few main pieces of the flight. So the two biggest pieces are the cost of the energy, the electricity consumed by the UAV, and the capital cost of how much the UAV cost when it was bought. So the Joby S4, its predicted price is around $1.5 million. So in order to pay back how much the UAV costs, for every hour it flies in its predicted 10,000 hour flight life, you divide that $1.5 million by that hour, and depending on how long the UAV flies, you add that charge to the ticket cost. So the same thing is done for the capital cost is also done for the insurance cost and the maintenance costs, such as costs that it would take to replace parts, such as the engine or motors. The crew costs, such as the pilot and the ground crew that are helping the UAV along, those are paid by the hour based off of who's working. The ground crew works during ground time, in which the UAV loads and unloads, and the pilot works while the UAV is flying. So once the total cost is totaled up, it's multiplied by 25% to account for indirect costs such that the company may incur, like marketing the service and things like that. And then finally, the ticket price is taking that overall total and dividing it by how many passengers are on the UAV. For the Joby S4, it's 4 passengers. So it takes like $3,100, divides it by 4, and you get a ticket price.
Right, so I just wanted to know, how did you go from the total flight cost to the passenger ticket price? You just answered 4 passengers. But how can you guarantee that taxi will always take 4 passengers? What if there is only 1 passenger? How much would this person pay?
The full price.
Right.
Or the flight.
I mean, the real answer is like airlines, right? They have a model for the portion of the flight that is filled and you derive the cost.
So this brings me to my second question, that how does these costs like compare to commercial flights for equivalent distances?
Commercial flights don't really fly equivalent distances because these are much shorter trips than.
No, but from LAX to San Diego, I can have that flight, right? That commercial flight. So how does that compare? That $1,076 for a passenger ticket, how does that compare for a similar commercial flight?
Check that actually. I would guess it would be less money, but I haven't double checked this. Does anyone know on the top of their head what a short flight would cost? Yeah?
I actually work in the avionics industry. I'm familiar with that, and short distance flights are usually relegated to charter flights, not commercial airlines. So the ticket price for a commercial flight, if it existed between LA and San Diego, which it might, probably $300-400 perhaps, depending on when you select your ticket.
Right.
The longer you go out, the less the price, the shorter the time until you fly, the lower the price. And then a typical charter flight would probably run about 3 to 4 times that price, which is what most individuals would take would be a charter flight.
Actually, there is a company that flies that. It's Jet Speed, yeah.
Yeah, Jet Speed.
It's very expensive.
So hopefully a UAV will be less than what it is currently. Because not all of us can afford charter flights.
But the big question, and we're not necessarily trying to prove that this is less or more expensive. I think we're trying to show what it is.
Right, but for me,
Yeah.
what
The economist
what
in
is
the room wants to
interesting
know.
is whether or not this would have actually a good market,
Yeah.
right? To be commercialized,
That's
right? Because it's still extremely expensive. So this is not for the average person. This is clearly for a very specific segment of the market. And my question is, how does this compare to what this segment is already doing? I mean, does it bring like any time savings? Or does it bring like any money savings, right? So that's what kind of interests
So
me.
you have to factor in the clout, you know, you go Instagram or Twitter. No, I'm serious. The people who could afford this are the people with like Hermes handbags and luxury coats.
Yeah.
And they post their photos on Twitter, right? So they want to be like, look, I'm in a UAV. That's
But
there is a market
those
for it.
people also kind of like the private stuff.
Well, it's a private, it's only for.
Right,
Yeah.
but it's still taxi.
Oh, yes,
It's
call it something
public
different. Call it
transportation.
luxury unmanned
Right?
helicopter.
But it's for luxury,
Yeah.
you have like a private transportation as opposed to, it's public luxury, but it's public still, right?
Yeah, so there's a few.
So how
Yeah,
will this
that was the question I was
segment
actually
actually take it?
curious about. So you'd calculate like the ticket price and all that, but then like, I'm assuming this is the break-even price, right? How much do you think or did you include a profit in there? That's my
I
question.
included a profit of 25% after
Or-
the break-even price for the passenger.
Well, is that profit or is that just like indirect costs? Because those are two different things, right?
Oh, I added indirect costs in the total flight cost estimate already, and then on
Okay.
top of that, I divided it per passenger, so like by 4. And then to that value, I multiplied it by 25%, again, for a profit margin.
Why 25% of markup? Why not 80?
Well, that would be if I was modeling maybe a luxury UAV, but I was trying to model public transport. Like, from what I got from my research, the goal isn't for these to serve people with Hermes bags. They are supposed to serve like working people.
We cannot afford that yet.
As UAV technology and infrastructure improves, one day we will be able to, and that is the ultimate goal.
We have several hands up. I want to acknowledge Saathvika's composure and it's incredibly, we are on the edge of our seat, so I can hardly wait to see what Luke has to ask you.
Okay, I'm trying to go in order, sorry, like.
Well, let's do Luke since I called on him and then you call on the next person.
I was wondering what the security process looks like for this. I know like we've all been at the airport and it takes like 30 minutes to get to security on a bad day. How does this factor into like what security checks do you guys do and how much time and how does this impact kind of like your whole kind of selling point where it's like you pay more, but it's like marginally faster than taxi. But like if you incorporate security waiting times and compare that compared to a taxi, we would just get it like on off, like, or maybe you would add as I would know, the waiting time to get into the taxi. But like how do these factors compare?
So I didn't do research on this, but I've been thinking about it since the helicopter question. I think that professor left, but I was thinking about that because I mentioned that vertiport infrastructure is, for now, in these early models, we're basing them around airports, right? But just because they're in or near airports, I don't think these UAVs will require TSA levels of security checks because you're not crossing any borders and you're not like endangering like a very large plane of people. Like, I think there will be security checks definitely, but not TSA level. But this is speculation. This is just based off of what.
But you can do a lot of damage with a helicopter, right? Even if you don't have a lot of people inside, you can do a lot of damage.
Do a lot of damage with the car too.
True. So
I will say, as a point of comparison, as a point of comparison, so long story short, one of my uncles flies private, so I have ridden in a private jet before. It's not that cool. It was like 12 minutes. We were repositioning the but it was basically like the checks for a private jet to any sort of like standard airport, like anywhere, are like almost done. They're like, you just make sure you're not on a no-fly list, and that's kind of it. So I presume that they would probably be able to implement similar levels of security for these flights, which, like you're saying, could be a massive time saver, especially at a nightmare airport like LAX. But yeah.
That's one thing I was gonna add on is because I have, I mean, I've never flown on Jet Suite X before, but I have heard about their procedures, and basically you just go through a metal detector real quick and then you check your bag and you're pretty much on your way. Like it's not like dedicated multiple lines at major airports to get as many people through as possible because there's only so few people that are actually going to be passing through security checkpoints.
But there's also fast lanes.
Yes, there is.
At the regular airports.
Yeah. Which are not always just faster than the regular TSA lines. I have personal experience.
I think in most airports, the time is the walking from the entrance to your gate.
Yeah.
And most airports are like LAX where you have to wait more than.
Yeah, 5 minutes.
So may I ask one question regarding the insurance cost? Is this a real number, or I mean, because with new technology, a lot of concerns on safety. I'm wondering if any insurance company would take this at this rate.
I'm lowballing the insurance estimate because of what you said. I based it off of the insurance for current small airplanes. Like if you're like a private, like small plane owner, like the Bush plane, basically not like a private jet, the insurance costs are they generally total up to half the purchase price of the plane over the course of its life.
Entire line.
Its entire life. So with a UAV that would fly like 10,000 hours and have a cost of around $1.5 million. I had like an insurance price of half of that split over every hour of its flight time, and those are added to the flight costs.
Okay, so that's how you calculate, not the real, any companies might have this number. Because I feel this is kind of a little bit too low for me. I don't know. I mean, even for passengers, do we have to buy extra insurance or something?
Yes.
They probably make you sign a waiver like at trampoline parks.
Or where to purchase the insurance,
No, I understand most of these cost estimates are probably not the best, but that's okay because I think the main contribution is the user interface you built for testing out different scenarios if you were wanting to enter this market. So I'm curious, how friendly is your user interface as far as changing different variables? Like, could I change the price per kilowatt hour of electricity, or could I change the price for like the percentage breakdown for marketing, for real estate hangar space, for the insurance, right? Or are those all fixed right now?
I'd say it's really friendly because I'm sort of a beginner myself. I commented the code really thoroughly, and the most easy thing that you can change is the zoom of the map. I have that right at the top of the code and label. You can change a lot of the variables. You can change the, like, for just pressing the UAV, like without even going into the code. You can change the passenger capacity. You can change the zoom of the map to like zoom it in and zoom it out. Like if you notice this map from San Diego to LA, it's more zoomed out and a more zoomed in map of Irvine. And if this is an even more zoomed in view that shows Long Beach and John Wayne airports.
Yeah, I think like if you know how to use code, this would be really easy to change.
Yes.
But for people, so maybe someone who's in business or something, right? I think everything should be a button. You click on it and then you either input a value or have a scroll bar. Because even if you just have to open a code and backspace 2 numbers, it's too intimidating for a lot of people. But otherwise, I did have 2 questions. What does UAV stand for?
It stands for Urban Air Vehicle.
Oh, okay. I thought it was unmanned air vehicle.
In the military, UAV stands for unmanned aerial vehicle. I was wondering if that was a standard industry term or is that?
Okay, because I was confused why there was a pilot, but never mind.
And that's why, I referenced in my presentation, I called these vehicles eVTOL because that's what they are. They're electrically powered and then they're capable, they have the vertical takeoff and landing capabilities. But, I mean, I could see where it would easily be confused, using UAV, because, it's so synonymous with, drones and especially with the military. So I can see where that would become an issue.
And then the second question was, I know you estimated the life capacity of the infrastructure by the flight hours. For UAV, for these vehicles, right? Is it important to consider the cumulative number of takeoffs and landings? Because I know in certain airplanes, right? I mean, the flight time is important, but also the degradation to the vehicle mainly happens at takeoff and landing. So even if you've only flown 600 hours, especially because these are very short flights, you might not rack up a lot of hours. You're gonna rack up a lot of takeoff and landings, and you're gonna have to replace that after a certain number. I don't know.
I sort of accounted for that underneath maintenance costs. So I mentioned there's a cost per hour for the mechanic, but there are also bigger costs for checkups. So there's actually a lot of checkups required for UAVs and I think small planes. There's like checkups every time you launch and land. There are yearly checkups, and every 3 or 4 years, there are like larger checkups like that are sort of complete or partial overhauls of parts. So during these like engine replacements, motor replacements, those would and especially like battery replacements, like I estimated that a UAV's battery would have to be replaced at least 3 times over the course of its life. And those replacements would be around $200,000 each time. Like those costs are included in maintenance costs. So it's like, especially for safety, it's important to make sure the UAV is running properly.
So how is the flight time different in those other maintenance costs? Is it just you're assuming you have to replace the vehicle for so many flight hours, or if you're doing all this maintenance, you're replacing the engine, you're replacing all those other parts? Should it just be like every so many years you buy a new vehicle?
Yes, so we're kind of predicting right now, like every 10 years, we would probably have to replace the vehicle if maintenance isn't enough. Because the UAVs will probably fly around 1,000 flight hours a year, and 10,000 hours is kind of lowballing it right now. It can range from anywhere to 10,000 to 15,000 hours, according to an article I read. But since the technology is still in its early stages, 10,000 is a good place to start.
Oh.
So it would fly, the checkups are supposed to be per flight hours and not per year, but with like 3,000 flight hours flown every 3 years, 3 years is a good place for a major overhaul checkup.
Oh, I get it. Thank you.
Where are you gonna park these
Can we
travel?
take this offline? I think the
Yes.
next presentation needs to go.
Okay.
Well, thank you, Saathvika. For engagement.
Yeah.
I have an exciting topic.
We do. We all want to be on we don't know if we want to be on Jeff's uncle's plane. We'll see what the price is. So I'd like to invite Melissa Lepe up. She's going to give us our keynote. While she's putting it together, there are a couple of people We sort of had natural introductions that occurred, and there are a few of you who haven't been introduced. I'd like to take a moment to do that. I'd like to thank our systems manager, Dr. Jared Sun, who is hopping up to save the day. And Jared is tired of me saying this, but when Jared walks in the room, you know everything's gonna be fine. And it's just priceless. I can't thank him enough for fixing every problem. To my left is Shreyans. He is an EE computer science major. And I think this is, well, I know this is his first time with us. Thrilled to have him. He and I met at the Entrepreneur Center at a celebration for an endowment that they just received. He was front and center making everything happen, and I just had to know who he was, told him a little bit about ITS, and he decided we were as interesting as he was, and we're looking forward to him joining a research team very soon. We have Kotaro. Kotaro is from the Japanese Railroad, really cool. He came here for his master's, went back to Japan, and decided he didn't have enough of us, came back for his doctorate. We're thrilled to have him.
Yes.
He brings his lovely wife with him, who is just as interesting and fun as Kotaro. Montana, my favorite high-speed rail advocate. He's wrong, of course, and we talked a lot about why he's wrong, and he talks about why I'm wrong. But I'm really thrilled to have him, and he has mentored several students in the program. Jeff is a TRIP alum, a superstar. He's a graduate of this program. And not only did he continue his degree, but he was accepted to what we call the accelerated degree program, where he's completing a master's and a bachelor's at the same time in civil engineering. And he keeps coming back and has the best questions, and his uncle has it blamed.
Well, he works for a chartered company, but.
We'll be reaching out. Raina, to my right, public health student. Fun story about Raina. She came to me and applied and said, I don't know if I fit in. I said, you fit in. And she did fit in. And not only did she fit in, but she has an incredible project. We're starting a new project with her. She's working with Professor Wu in public health. Her goal is just study law, and she now, based on what she researched, is interested in environmental law because she researched the impacts of transportation infrastructure on the climate. And finally, last but not least, Saba.
Oh, hi.
Saba is a new, relatively new PhD student, and she comes all the way from Bangladesh. And I know how far Bangladesh is now because we had a spirited discussion. Only with engineers can you play a game, and they go way off into the weeds about what's closer, Ghana or Bangladesh. But we were playing a game to see which student came to us from the furthest location. We had a student from Ghana, we had Saba from Bangladesh. It was just, Montana was in charge, and he could not make the call because there was just not enough data. So she ties with being the furthest new transportation student. With that, I'm going to turn the time over to Melissa. It's about.
Victoria, I mean.
Who did I forget?
June, I mean, I don't know if friend.
June, yeah, June. I kind of thought he introduced himself earlier, but yeah, I think June is one of our doctoral students. He was supervising one of our students. Is there anyone else who didn't get introduced as we were chatting? Parents, my gosh, most important. Without them, we would not have Alex, and without parents, we wouldn't have any of us, and I won't go on about that, but really appreciate them. I learned from the sign-in sheet that it's no surprise that Alex is researching aviation because he gets it from both sides of his family. He's got dad, who you heard from in aviation, who's at Panasonic as an analyst, and has lots of really good information, as we now know. We have mom, who is an educational media specialist. So we certainly know where he gets all of his great media skills and that fancy flipping slide thing, which was just amazing.
Yeah, thanks,
So-
thanks to the software team at Google Slides for that.
Thank you. Well, thank you, parents. Thank you so much for your support. So Melissa, it is noon. Melissa's going to give us a great keynote presentation at about 12:20, 12:25. We will break for lunch.
So I will try not to keep you all for lunch. I know you've heard a lot of great presentations today, but hello, my name is Melissa. Today I'm going to give you a keynote presentation on the road to air taxis. It's both a reflection of kind of my own journey to this topic, but kind of the little things that influence my path and kind of where I see this kind of moving forward. So just to kind of touch base a little bit about who I am. So you see my face, so that's great. but I am a PhD candidate in the Mechanical and Aerospace Engineering Department. Actually, one of my faculty advisors, Professor Quinn, is actually right here in the room, and I got to advise Alex and Vika through their work. I know you all had some really great questions about AAM, and would be happy to talk more about it even during lunchtime as we move forward. But I actually did my undergrad here in UC Irvine as well. So I did my undergraduate degree. I was graduating class of 2022. So I did my degree in aerospace engineering. But just to rewind a little bit, kind of the way that I got there and where I'm at now wasn't completely a linear road. It looked a little bit more like this, where you kind of go one way, you're not really sure where to go next. So I really want to talk a little bit about how this kind of came to fruition, especially as some of you are undergrads advancing and moving on to then potentially pursue a job or grad school. Some of your high school students who are now thinking about where you're going to end up going in your future trajectory. Really, my journey kind of starts even before myself. It was a journey that was based off of, I think, dreams, specifically my parents' dreams. So my parents came from Jalisco, Mexico. So this is just a picture of Guadalajara, which is where my mother is from. And this is just a picture of my family. I know you can't tell, but I am the oldest of the three that are there. But really, they came here looking for better opportunities for their own families and potentially the future family that they. So as I was growing up, a really big thing that they talked to me about was the importance of education and going to college, which is something my father didn't get to do. And my mom, when she came here, was very limited with the actual knowledge that she did have. None of that translated over. So she kind of started from zero. But really, they wanted us to have a better life and better opportunities. And so that's kind of where I began to think of myself as kind of like this dreamer. I'm like, oh, I can do anything, I guess. So my parents were always very motivational in that sense. And if you ask me, Melissa, what do you want to be when you grow up? I would say, it depends when you asked me. When I was about 5 years old, I would have told you, I'm going to be a doctor. I don't like blood. I don't like people. I don't know why I thought that at the time, but it is what I thought at the time. Then I moved on a couple years later. I wanted to be an archaeologist. And really, I think this kind of stemmed from that love of watching shows with like dinosaurs involved. So that's kind of where that inspiration drew from. But ultimately, this also spiraled into different ideas, such as being a writer and being an author. I wanted to kind of inspire and also channel some of my creativity in that sense. I wanted to be a marine biologist. So there was a lot of avenues that I considered early on in life. But really, now you're thinking, okay, you told me you graduated from aerospace engineering. You're talking about air taxis. So how did you get there? Well, it was kind of taking a little bit of a leap. So originally, when I was around in middle school, was my first formal introduction to what engineering was through a program that, or a particular day in my middle school where they called it Introduce a Girl to Engineering Day. So this is a day where we had a couple of engineers come to my middle school one day where they sat all the girls out in the cafeteria and they had us do this bridge. So I know a lot of you are familiar with this, especially as you're going into engineering, right? You've probably seen this spaghetti bridge with like marshmallows a couple of times. But really, it was the first time anyone had ever talked to me about engineering. And I thought, wow, this is really cool. They do things with math, they do things with science. I really like those subjects. Maybe that's something I can pursue. So then I started thinking about and getting excited about potentially taking engineering classes, especially as at this point was starting to now move into and transition into high school. So when I got into my high school curriculum and I kind of asked a little bit about what the opportunities were, they told me, we don't actually have any engineering classes in this high school. So the closest I got to engineering, at least at this stage in life, was taking mostly, you know, your math courses and an introductory to physics, as well as some other related work such as like chemistry and biology. But really, there wasn't a formal introduction to engineering, but it was still something that I thought I wanted to do and piqued my interest. And by the time I got to the point where I had to go in and apply for college, I thought, okay, I thought I want to do engineering, but I actually don't know what kind of engineering I want to be in, especially as now the time is coming up where your applications are starting to come up and you're starting to think a little bit more about these conversations. So what did I do? I went online and I took an engineering major quiz to figure out what is the best suit for me based on my personality, my characteristics, my likes and dislikes. And lo and behold, this quiz told me I should do aerospace engineering. So this is actually something I talked about with my physics teacher at the time. And I was like, can you tell me a little bit more about whatever it is that you do know about this? I did a little bit of my own research, but at the same time, didn't fully know exactly what I was getting myself into. So it was a little bit of a leap of faith. I thought it could fit. I liked the sound of it. I thought it sounded quite interesting, but I didn't quite know if it was going to be the perfect fit for me. So then I went along, I went to UCI, so I'm now in the UCI Seminole School of Engineering at this time, and that was no shocker since I did tell you I graduated from UCI. But there was something that just really was kind of weird about this experience. Now that I was in college, all of my life, my parents kind of led up to this, you should go to college, you should go to college, it's so important. And now that I was in college, I was like, okay, now what do? I'm here, but I don't know where to go or what I should be doing. So my goal kind of became, you're going to graduate. And then you're going to get this really good job and you're going to make some money. You're going to help your parents out and we're all going to be living together and it's going to be great. And I walked into one of my first engineering courses. So formally, it was an introductory to programming. So I actually took this math lab course, which is a required course. If you are in any of the engineering disciplines, you're familiar with this course that you're going to take. And I remember the first day of class, my professor just kind of introduced the topic and he just kind of asked by a show of hands, how many of you are familiar with any sort of coding, even if it's not math lab? About 2/3 of the class raised their hand. And I sat there and I looked around and I was like, oh, did I miss the memo? Like, was I supposed to know this as well? I didn't know anything about it. And that's kind of when I started realizing maybe I wasn't ready. Maybe I picked the wrong path. Maybe this wasn't what I wanted to do. Maybe my peers were much more advanced than I was in some of these areas. So I started going through some questions of like imposter syndrome. So if you know what that is, I think maybe all of us have experienced it at one point. But it's just that feeling that no matter what you have accomplished or your current accomplishments, you feel like an imposter in that particular environment, no matter it is where you are. And this was something that I was really struggling with at the time. I was feeling like I made a really good decision. And ultimately, I told myself, okay, we're going to give it a year, 2 years tops. And if it doesn't work out, there are other options. But I really tried. I tried really hard in those classes. And I think there were certain things that really made a difference in my life. Some of those being community elements and finding people that I also thought, hey, they also felt the same way that I did. Maybe they didn't have the opportunities that some other folks did growing up. And maybe they also were not as familiar with it together. And so that kind of also motivated me as we were both in it together. We were kind of sticking along with it. And then I heard a very interesting presentation in one of my dynamics courses about a program called UC Leads. So the UC Leads program is the University of California Leadership Excellence through Advanced Degrees. And it's specifically a program that spans across the different UCs, but it's meant to offer educational and economically disadvantaged sophomore and some juniors who are expecting to complete a 5th year, an opportunity to kind of go through the motions of preparing for a PhD. And at the time, when this particular speaker came up, it wasn't a very formal presentation. It was like, can I take the first 5 minutes of your class and just introduce something real quick? And one of the questions that that speaker asked was like, are any of you interested in pursuing a PhD? And my first thought was, I don't know. I was never asked that question before. And after this presentation, I was a little bit intrigued about maybe pursuing the idea of it. And as I was walking out of the class, actually, someone that I knew who was a year ahead of me was a part of this. And he told me, hey, Melissa, I think you should really apply for this. I think you'd be a great researcher. I think this could be a really great fit for you. And I think at the time, that was the first time that I was like, me? Like, I don't really know anything though. You think I would make a really good researcher? And I kind of was like, okay, maybe I'll give this a try. I think it could be interesting to be in a PhD, especially when I never really saw professors that looked like me or professors that address some of these issues that I was particularly having. So I was like, this could be really interesting, especially then looking at some statistics of how many Latinas actually went into pursuing PhD degrees, I was like, wow, there's not that many of us, but we could make so much of a difference by adding in some of our voices into the current conversations that are happening. And they're important conversations, as many conversations are being taken in this room. So I joined UC Leeds, and it really helped me prepare for eventually becoming and for getting into a PhD program. So I was able to do some research. I did research at the National Field Cell Research Center here at UC Irvine. It started as a summer, actually, just like you. And then it progressed into a year. And then during my second summer, I did summer research at UCSD. So I did research on like geomicromechanics, which was a little bit different, but I wanted to try something else out. But really, this kind of also pushed me into, I really like the sustainability aspect of the research that I'm doing, which is the research focus that I kind of wanted to move forward with as I pursued a PhD. I found a lot of great mentorship opportunities. So I was mentored by several graduate mentors, as some of you have here today, and also by just PIs and other people who really helped inspire and motivate me to keep going. And they gave me the ropes and the ends of like how this all worked out. I also found community within other folks in the UC Leeds program. I found community with other students in the lab, and it was really a good experience for me overall to see and feel like I kind of belonged in that space or could belong in that space. But it also helped me develop a little bit professionally. So I was like, okay, I don't really know what I even need to do to apply to a PhD. So it was really helpful to figure that out and have someone kind of teach me the ropes along the way without, I don't know if honestly I would have done it without it. It's because I wouldn't have known what to do or what to prepare or how to prepare. But aside just from now preparing for this PhD, I was also participating in a lot of service. So I thought service was always something that was very important to me and still is important to me. And at the time, I was very heavily involved in MassEO. I know there's some math majors in here, so I don't know if any of you are familiar with this program. I see some nods, but it was founded in 2014, and it's a program that's supposed to inspire and support the interest in math for students, specifically middle school students in the Santa Ana communities who may not necessarily have the best access to math or other resources that inspire and motivate them to pursue degrees that require math. Since math is such a hurdle a lot of the times when people are considering STEM degrees, it was meant to be a resource for them to collaboratively integrate math into their lives. So we made a lot of fun projects to them, and I was one of the mentors and then became like a room mentor, and I really, really enjoyed it. We even got to do the infamous little bridge project that I once did, except theirs was with gumdrops instead of marshmallows, but you know, it was that same concept, and it felt like now I was on the other side of it. I was like, wow, what once inspired me is now kind of inspiring them. And it kind of led me down this road. So I don't just want to be a researcher. Maybe I want to be a professor at some point in the future. So that's kind of what inspired my kind of why I want to be a professor in the first place and why I want to pursue this PhD. So as I was going through this and thinking about what are the things that I want to do with my life and what are the things that I want to pursue, I decided I didn't want to give up one or the other. So I decided I wanted to do my research while also developing some of the pedagogical skills that I wanted to be in a professor. So I'm currently a part of 2 labs. As you can see, I have 2 co-advisors. One of them is here, as I mentioned, Dr. Jacqueline Quinn under the Aircraft Systems Laboratory. And we do a lot of technical work there as well, but in collaboration, we've also done work with the STREAM Laboratory, which is done by Dr. Natasha Buswell, which is also focused more so on engineering education work. So from both of those labs, I've been able to kind of peek in both of my interests. I've studied, you know, a variation that exists in aircraft overflight noise and how that may impact communities. And again, community impact, that kind of sparked the element for how air taxis would then fall into that equation. I studied Hispanic and Latino student belonging in engineering with the STREAM Laboratory. And that also kind of pushed this idea of like, what does servingness look like? And what are the things that we do to serve communities? And ultimately, there was a little click that happened where I was like, I want to merge both of these backgrounds, these interests that I've been kind of dabbling in, initially maybe a little bit separately, but now let's focus on kind of putting them collaboratively. And that kind of then moves on to my research goals and the objectives that I have with this work, which is to create a framework that for advanced air mobility implementation that centers around the community needs and goals. And it does it through a socially equitable lens. So it considers both of the vehicle performance side, some of the things that Alex and Vika have been talking about. And really it also integrates then how it applies to those particular communities that it's intending to be part of. And so I know we've already talked a little bit extensively about what advanced air mobility is. So I won't get into it too much, but we've talked about this concept of it being air taxis. It's meant to promote safety and sustainability. There's so many different concepts that are coming to mind. So much support intra and intra-city. So there's a subset that then comes in from this bigger, larger term. We talk about urban air mobility, which moves between in just regions in a city, or regional air mobility, which is meant to connect two separate regions. So it's an avenue of connecting things. And there's so many different use cases that we consider. Some of them are passenger transport. We talked about cargo as well as being another thing. Emergency relief could also be another category. And there's so many different concepts that are in the market. If we looked at the timeline of when some of these vehicles are expected to enter, relatively soon is my answer. So some of these are actually planned to do some initial testing outside of the US mostly, at least as they kind of do some of their initial concepts. The only one that's looking at doing testing in the United States is this last one, WISP, by around 2030. And the reason they're also so far back is they're expecting some autonomous vehicles so their system is autonomous, so no pilot. So there is a large market of these vehicles coming in, and they sound very interesting, but also, as we said, a little scary, maybe. So that poses my question, just based on what you've heard, who of you thinks you'd actually get on one? Okay, so we have some good hands in the room, but we also have some hesitation, which is actually very normal. And is then bringing in this community element piece is there are so many potential benefits that have been outlined by people who are marketing these vehicles, whether it's reductions in emergency response time or creating new employment opportunities to providing relief in disasters to eliminating congestion in some areas. There's so many different elements that these vehicles can tap into. But really, the big question that I think even in this room has been brought up is integrating these vehicles in a responsible manner is going to be to their future success. And you're asking, why is this so important? Is it touches on every person's aspect. We talked a little bit about how these vehicles are a mode for access. Transportation in itself is access. It allows us to get to a hospital if we need emergency care. It allows us to get to our daily lives and commute. It allows us, and it brings food to us from different regions that we might not otherwise have. So really, it helps mobilize communities from different places. But it should be created for all in mind. So we talked about who is AAM for, and we talked about that question of, is this only meant for people with their med bags? And that's a fair question, and it's a question that a lot of people have. And it's a statement that's been said is, these vehicles aren't intended for me in mind. And really my work is hoping to transcend a little bit of that is, instead of thinking about just who is this for, outside of like cost, is how is this intending to serve the communities that it's meant to be around? So that's taking into consideration new things such as like infrastructure that needs to be developed for these to be sustainable. It talks about into the potential community impacts. If we look around airports, a lot of the people who are currently impacted by flight operations are underserved communities and minoritized communities. And if we don't plan for the integration of these responsibly from the very beginning, those are things that are expected to also happen with this new entry market. So it's important to understand the implications that it'll have on the communities that we have. If we can involve communities in the early process and the development, and not just asking what you want, but actually bring them in as part of the co-design process, that is where we're going to be not necessarily just reactive, but proactive to design something where we're able to provide fairness in mobility and accessibility and ensuring that the needs of the community members are actually met. So we're actually wanting to take in community partners, and we're trying to make this something that is a co-designed situation where we're able to not just say, okay, this is what it's gonna be, and you have to accept it whether you like it or not. It's something that's meant to be something we create together for them in the first place. So it's designing with communities, not for them. And so as I kind of conclude a little bit, there are some lessons and key takeaways that I just want you to take into consideration and things that have been pivotal for me as you continue moving forward. Community was a big part of my life, and the people who are in my life are the people who motivate me, the people who keep me going, and the people who really, sometimes when days are hard, they drive home why it is that I'm doing what I'm doing. I think another important element has always been mentorship. Whether it was being a mentee or being a mentor. I think one of the greatest pieces of advice I was ever given, and I'll give it to you, is no matter the stage of life that you're in, you can always be a mentor and you can always find a mentor. So there are always going to be people who know a little bit more about you, and there's always people who you can help out along the way based on your own experiences. So I encourage all of you to, now that you've done some of this, is to actually go on and mentor some students as well. Share your experiences, and it's been my pleasure to also mentor some students throughout this program as well. And then the last is to challenge your research. So ask those difficult questions, you know, how is this going to be inclusive? How is my project going to be equitable in the long run? Or am I excluding a certain subset of people when I'm doing my data set? And allow that to be transformative, really, as you grow and you move on. And so the road that I took to air taxis wasn't always clear. And it was shaped by curiosity, challenges, and honestly, a lot of the people that I met along the way. And all of the different detours that I had kind of ultimately led me to where I am at right now. But as you're all going on and planning what that road looks like for you, think about the impact that you can make, the solutions that you can create, and the path that your journey will open up for other people. And with that, I'd like to conclude and open up the floor for any potential questions that you may have.
I just have a comment about the healthcare aspect of this is enormous in that if you want equity amongst healthcare, if there was like a service for like donated organs and how that would get to communities that don't necessarily are not, and I would hope this wouldn't happen, but I think in my brain, I think that people who have priority might be in more urban settings when it comes to like needing a heart or lungs or whatever. This could be potentially great for getting those kinds of services and resources to places that not necessarily would get it.
Right, and exactly. I actually was at a conference earlier in July where I spoke to someone who was from Canada working with some local tribes, specifically because they wanted to do some testing with them in regards to some advanced air mobility operations, simply because they're so remotely located from other areas. They don't have access to healthcare, which is a really, really big impact in their communities. And it's very difficult to access via other ways. So because of the landmarks, it's really difficult to get a car through. So the only way that actually makes sense is honestly through these kind of aerial vehicles. So currently they have kind of like a helicopter system, but it's not even fully integrated into that community space. So this is a bridge that particular person was hoping to bring in as well with the introduction of advanced air mobility operations.
It's very interesting.
So yeah, very inspiring story and a lot of good lessons and congratulations for finding your passion in this area. So I have one kind of a technical question. I know that many of these vehicles are kind of a battery electric.
Yeah.
So I'm wondering, I mean, you've been working with what is the lab? How about hydrogen?
There are some
fuel
hydrogen,
cell.
there are some hydrogen fuel cell models that are actually developed, although they make up a lot smaller portion of the current market.
Okay.
So a lot of the market, if I had to kind of quantify it into chunks, Most of it is electric, then there is a subset that is hybrid electric, and another piece that is actually incorporating hydrogen.
Mhm.
I think the only thing with hydrogen, we actually had a student who looked into hydrogen into commercial flights. That can be difficult is actually building the systems that go around that. So hydrogen, one of the things that's really difficult about it is they require those cryogenic tanks that are very, very big in volume. And depending on the size of the aircraft, they actually have to be created differently, which is if anyone's familiar with a blended wing body, it's basically an aircraft that looks like a pizza like this. So the fuselage in the back is a lot larger and it's able to accommodate some of those fuel tanks that may not originally be accommodated in traditional kind of designs. So the design is something that would also have to change, but a lot of the thing about these vehicles is, you notice the pictures that I showed, they all look very different because they're intended to serve different markets and be used for different purposes. So, but there are models that are looking into that, and that also may be another potential avenue for a sustainable manner of integrating some.
So you see, I mean, at least in the near future, battery electric are more meaningful for this urban air, you know.
It seems the
UAM,
market
like
is-
regional, not you know, continental, this kind of like.
Yes, it seems the market is going more towards the electric right now.
Mhm.
And that's kind of where even most of the studies and more of the development in terms of like battery capacity and things like that is going into is more geared into the electric side.
Because I have a follow-up, I mean, again, getting back to the safety issue. I mean, with the lithium battery, you know, there's a lot of safety concern, right? There's a lot of story regarding, you know, electric cars, you know, how they can, you know, the fire cannot be extinguished easily. I'm wondering if that is a concern.
Yes.
In addition to, you know, flying is
No,
already a
there's-
safety concern, right?
There's so many
Electric-
safety concerns. There's safety concerns for the passenger. There's a study that we've done that looked at passenger safety. One of them talked about people are concerned from the moment of even before they get on, they're concerned about what it looks like to be in like a TSA checking. Is my data gonna get leaked? That's another concern. They're concerned while they're on the plane of like, well, now it's a really small, tight setting. What if I don't like the person that's sitting next to me next year? That's a valid concern. There's also that safety question of like, if we're bringing autonomous vehicles into it, that's another element to add to safety. So there are so many things that go into that safety question. And I think Alex was the one who showed some of the concept of operations that were happening. So those UAM corridors, the FAA highlights those as concepts because right now they're still in the concept stage. As the market continues to mature, there are things that are going to come out, but there are regulations that are being in place by the Federal Aviation Administration. So they have currently redefined advanced air mobility operations into their private sector of like flight. So they've now made a subset claim around that. So they do have to achieve a certification process for these vehicles to even be able to enter the market. So these are not just going in without no regulations at all. Because ultimately the safety of people, both at the passenger level as well as the people surrounding those communities is going to be a very big part of this.
Yeah, I mean, you talk about regulation, definitely, you know, electric vehicles, right? Like a Tesla's design of this, you know, handle thing, right? So regulations many times are, you know, really, you know, lacking with this new technology. I won't be surprised. It might be the same with, you know, this, you know, flying cars as well, maybe even more so. You know, as you mentioned, different companies can come with different designs and but I do think, you know, I like your idea about you're proactive, but I do think, you know, safety should really be a major issue to be proactive, not after, you know, have all this kind of high profile accidents. Then we come back, oh, we should have a mechanical handle. That just makes sense. Thank you.
Out of curiosity, where are you gonna park all these vehicles?
So there are stations, and I didn't mention the infrastructure too much for the sake of the time, but there are specific infrastructures designed for these vehicles. They're called vertiports. And these vertiport locations are designed and comprised of like both a pad for the vehicles to take off, like off if we're talking about urban cities where a lot of these operations will be taken off vertically. So kind of like in a helicopter setting, but they also have areas there designed to accommodate recharge density as well.
Where are these areas?
Well, exactly. So
Where would these be?
yes, so they don't currently exist, but vertipads are assumed to be in current airports as well as infrastructure that can support this sort of vertical landing operations. Some of them can even be on top of very commercial buildings. We're talking about even like on top of a mall. So if you want to go shopping, they might have vertipads installed up there.
Like the Amazon warehouse.
Yes, exactly. So anywhere that currently there is helipad, that's a particular viable vertiport. There's also new infrastructure that's demolished. The only thing is have to be able to make sure it meets the federal aviation clearance restrictions that are in place. And they have a guide right now that's they've exported, I think, up to 2023 with the most current vertical design guideline. But that's part of the parking and where these would be situated. And they're also at different levels because they can be taking off from the rooftop of different buildings. Some may be coming from the ground. Some may be coming from a certain altitude or elevation. So all of that is also related to some of the work that Alex is doing with finding out those kind of airspace regulations and current airspace vehicles that it may potentially interact with as well as they go about and enter a particular UAM. Okay, I think the lunch is ready, so do you want me to just close if that's no more questions?
Yes, please. And let me again thank all of you for attending. I can't thank you enough for the support of these programs. People hear me say a lot that I have the best job on the planet, which I do, obviously, because I get to work with all of you and amazing emerging scholars. And I really appreciate all your support and let's change. Listen.
Thank you all so much for coming and thank you to the students who have put in a lot of hard work throughout the summer. Thank you to the parents who I know who have come here from San Diego, and thank you to the faculty members, the mentors who have supported the students along their journey. Thank you, Victoria, for facilitating and making all of this happen. And we thank the sponsors as well, who ultimately make all of this possible. So thank you so much.